So the directions graph the hyperbola given by 16y squared minus 9x squared equals 144. Well, okay, you do need to write this thing in standard form. And the standard form has a 1 as a constant by itself, right? We have a 144, so what do we have to do? To put it in standard form, divide everything by 144 to get 1 on the right side. Okay. Now 16 over 144 reduces. How many times does 16 go into 144? Yeah. So 16 y squared over 144 reduces to y squared over 9. Minus 9x squared over 144, what's that going to reduce to? 9 goes into 144 16 times, so it reduces to x squared over 16. So now it's in standard form. And it's in the standard form where you have the y squared term first. So it's y squared over a squared, what we call a squared. We always call the denominator associated with the positive term a squared. Minus x squared over b squared equals 1. So it's in that form. So when it's written like this, a determines how far from the center you go up and down. Not that you need to remember it that way, right? All you really need to remember, and this works for ellipses as well, is how far up and down you go is the square root of the number underneath y squared. That's the easy way to remember it. So how far up and down are you going to go? 3. So from the center, which is always 0, 0 for ellipses and hyperbolas in this class, you're going to go up and down 3. So 1, 2, 3. 1, 2, 3. How far left and right are you going to go? Yeah, the square root of the number underneath the quantity involving x squared. 4 to the right, 4 to the left. And then it's, okay, remember, you're going to have to remember this for the final. If you get a hyperbola versus an ellipse, since it's a minus in between the x squared term and the y squared term, you have to draw the box containing those 4 points, not the oval shape through those 4 points. If it were a plus right here, you'd just draw the oval through these 4 points and you'd be done. That would be your ellipse. But that's not the case. So you draw the box containing those 4 points as midpoints. And then remember, all you have to remember is the extended diagonals of the box are the asymptotes that we use as a guide to graph the two branches. So draw the extended diagonals of the box. Whoops. There's one. And here's the other. They go through the corners, opposite corners of the box. Now, does this hyperbola open vertically? In other words, one branch opening up, one branch a smiley face, one branch a frown? Or does it open horizontally? One branch going to the left, one branch going to the right. Vertically, how do you remember? Just remember the positive term involves y squared, and y controls the vertical, so it opens up and down. That's how you remember it. So you're going to draw one smiley face. That's not a good start. It's hard to draw on this thing. Okay. If you're me, if you're an artist, it's probably easy to draw. So as it goes to the right, it should get closer and closer, and as it goes to the left, it should get closer and closer to the asymptote. The other branch should look like a mirror image, but going down instead of up. And as it goes to the left and right, it should approach the asymptotes. Okay. So the graph in blue is the only part of this drawing that represents the hyperbola. And I want you to remember this. I didn't label it in the last picture. But this low point of the upper branch and this high point of the lower branch, these are called vertices, V for vertices. That's the plural of vertex. So, you know, you've seen a vertex before, right? Every parabola has a vertex. But these aren't parabolas because parabolas don't have asymptotes associated with them. So up here, the vertices are on the left and right of each other in the first example. When it opens vertically, the vertices are vertically away from each other. Any questions on how to graph a hyperbola? So if you can graph an ellipse, just think of it this way. If you can graph an ellipse, you can get that box, right, with those 4 midpoints. And then you just remember diagonals and remember how to figure out whether or not it opens up and down or left and right, and then draw the curve so that they follow the asymptotes as they go either to the left or to the right. Okay? Is this a function, by the way? Is a hyperbola a function? Does it pass the vertical line test? It's not a function. Neither is an ellipse or a circle, right? Yeah. So we're graphing non-functions now.